Hey everyone, this is Maths Guy channel here. Today we're going to be going through circular functions of sine of x and cos of x. And today we're going to be we've done the algebra behind the trigonometric functions of sine, cos, and tan. But for this video, we're going to be going through the graphs of sine and cos of x, and tan of x will be in its own separate video. Okay, so there's two new terms that you need to learn when you're talking about the graphs of sine and cos. That's the period and the amplitude. So you can see in the pictures here, this picture of sine and cos. And the period is the distance between two cycles. Let's say, for example, the top picture of sine of x, like the distance between the two peaks, like the top parts, or the distance between the two valleys, the distance is the same. So that's the period, the distance of the period. And amplitude is sort of the vertical distance, so that's the distance between the minimum values and the maximum values. If you look for these functions specifically, the period is 2 pi, the amplitude is 1, because its maximum is 1, and then its maximum y value is 1, and the minimum y value is -1. The mean position is 0, because which is kind of like saying what's the y-intercept. The domain is for all real numbers because it's currently unrestricted. And for most functions, in most questions, it'll probably ask you to get a restriction. Otherwise, you have to give us the general solution, like in one of the previous videos. And it's a many to one correspondence because it's one unique x value, so it passes the vertical line test, but does not pass the horizontal line test. You can notice here that sort of terms they look very similar, but like the out of phase is the correct term. So like the horizontal shift is out by pi on 2, and if you just change one of them by pi on 2 in the correct way, then you'll get the same with the other function. Okay, so this is a statement of periodicity. So about like actually there's really no need to go through that, but it's just talking about the shifting of the functions. Alright, so this is just sine and cos of x, its easiest forms. If you go into Desmos here, this is sine of x like that. This is cos of x. And see if I do I shift this negative. Line 2 like that. You see these functions become the exact same, and they have infinitely many solutions. So when you put everything together, so a times sine of, so this is the general form of sine and cos, as you see sine here as an example. So the amplitude is absolute value of a. So that means, for example, you can't have a negative amplitude. I mean, you have the graph will flip, but the amplitude stays the same. Let's say, for example, I have sine of x here, and I do negative sine of x, like that. So obviously the values are flipped, but the amplitude is still 1. It's just a negative sign in front of it. The period is b. So that's the distance again. The phase shift is c over b. That's the left and right sort of shift. So I go here and I go. Actually, if I can just go here. So this is the amplitude. So how tall it is. It flips here. So the negative is just tells it flips, but the actual value, the amplitude is an absolute value. So whatever number it actually is, b is your. B is how stretchy or how thin it is. C is a sort of shift here. C is moving left and right. And K, as per usual, is up and down. Okay, so when you have the case of this, something else to learn is a combination of functions. So like, for example, if a question asking you to find f of x of sine of x plus cos of x, and it's asking you to sketch it without a calculator, you have to use what's called addition of ordinates. And what you do here is you write so sine of x for given period, so 0 over an x over 2 pi for simplicity's sake, and you have cos of x 0 x 2 pi. And what I'm saying is that you look at the coordinates of each of the graphs. For example, here, it's 0, sine is 0, cos is 1, and you add these values up together, and you literally just add the values up together. So I write sine of x plus cos of x, and I write it for the domain of 0 x 2 pi. And you say that okay, so at 0, so you're adding 0 and 1, and then so the green line here is the function. And this is how you get the shape of this. If you have, in this case, these two have the same cycle, the same period. But sometimes if you don't have the same period, for example, if you have sine of 2 of x, like that, you have to make sure that you do adjust the domain so that you have at least one cycle, one period of the other function, so that it adjusts this accordingly. And you get really, weird shapes like this. And yeah, that'll be all.